a particle moves according to the law of motion. Okay, this is the displacement, where t is measured in seconds and s in feet. In part A, we have to find the velocity of the particle after 3 seconds. So this is the position or height function, in this case position. So to find the velocity, that's the rate of change. So we find the derivative. So for part A, the velocity, let's say v at any time t, is, let's find the derivative of this function. That's 3t squared minus 24t plus 36. That's the velocity at any time t, but we want the velocity after 3 seconds. So v after 3 seconds is, just replace t by 3. So 3 times 3 squared minus 24 times 3 plus 36. Now use your calculator or simplify, and this comes out to be -9, and that's the rate of change, so feet per second. Part B, when is the particle at rest? Rest means it's not moving, so the velocity 0. Okay, when means we need to find the time. So we set the velocity 0, and we found the velocity here, 3t squared minus 24t plus 36 equals 0. Now we want to solve this quadratic equation for t. 3, 24, 36, 3 factors out, so t squared minus 8t plus 12 equals 0, and we can divide both sides by 3. So we got a trinomial inside here. We want to factor that trinomial, that equals 0. So t squared, t 12, 6 times 2, 12, 6 and 2 make 8, so 6, 2, minus minus. Okay, that means t equals 2 and t equals 6. So when after the particle starts to move, after 2 seconds and 6 seconds, the particle is at rest. Okay, so at 2 and 6 seconds. So we have the following chart kind of. So at 0 it was not moving, at 2 seconds it's not moving, so it was going to the right, then now it starts to come back to the left, or anyway the particle is not moving at 2 and 6. It could be moving to the right, then it starts to move to the left, okay, and 6 and all the way. So at t equals 0, obvious trivial case. At t equals 2 and at t equals 6, the particle is at rest. Now part C, when is the particle moving in the positive direction? So we need to consider 3 time intervals. In first 2 seconds, 0 to 2, or after 2 seconds, and before 6 seconds, and 6 to all the way. So we need to consider 3 intervals here: 0 to 2, 2 to 6, and 6 to infinity. We pick a representative from each interval, and just we can take any number. Let's take t equals 1. You don't have to show 3, t equals 7, and plug that into the velocity function. Okay, so we want to plug that into the velocity function, vt, and the velocity function is, we found here, 3t squared minus 24t plus 36. And if the velocity comes out to be positive for this t, that means the particle is moving in the positive direction. If the velocity comes out to be negative, then the particle is moving in the negative direction. So we have to test this velocity function for these 3 intervals. So we pick a representative and plug these numbers into this velocity function. So let's plug in t equals 1 into this velocity function. So v at 1, plug in t equals 1 here. 3 times 1 is squared minus 24 times 1 plus 36. and use your calculator or just the work, it will be a positive number. Okay, this is a positive. That means the particle is moving in the positive direction. Do the same thing here. Find the velocity at 3, v3. That comes out to be negative. Okay, and similarly, that means the particle is moving in the negative direction. That means backward. Okay, plug in t equals 7 here. Then v7 will be positive. Okay, so thus the particle is moving in the positive direction in the first 2 seconds and after 6 seconds. So the answer is first 2 seconds and after 6 seconds. In part D, we need to find the total distance traveled during the first 8 seconds. So it's 6, somewhere here is 8. So let me go through this timeline again. Somewhere here is 8. So in the first 8 seconds means, look, in this case the particle is moving in the positive or in the right direction and left, right. So we need to find the distance in each case, and we need to find the sum of those distances. So the total distance traveled is, so distance, that's the s at 2 minus s0. Okay, and we take the absolute value because the distance is always positive. So this will be the distance traveled in the first 2 seconds plus 2 to 6. So do the same type of work. Okay, let's see. S at 6 minus s at 2, absolute value, plus in the first 8 seconds at 6. So s of 8 minus s of 6, absolute value. Okay, this s is the position or height. It was given at the beginning of the question. So evaluate the s at 2. Just plug in 2. Okay, and if you plug in 2, what is st, by the way? Let me recall. St was given in the question. That was t cube minus 12t squared plus 36t. So we're going to plug in different values here. So s of 2 will be 32. Okay, minus, sorry, s of 2 is 32 minus s of 0 is 0, plus s of 6 is 0 minus s of 2 is 32, plus s of 8, that's 32, s of 6 is 0. Okay, so this is 32. 0 minus 32 is minus 32, negative 32, but absolute value makes it positive. 32 plus 32 plus 32, that's 96 feet. Okay, and we still have part E. What is the acceleration after 2 seconds? So let me answer over here. Part E, acceleration is the rate of change of velocity. So we have the velocity function here, which is the derivative of position. We need to find one more time, the derivative one more time. So acceleration A is the derivative of velocity function. That's the derivative of this function. So 2 times 3, 6t minus 24. This is the acceleration at any time t, and the question wants to find the acceleration after 2 seconds. So plug in 2. So A2, 6 times 2, 12 minus 24, negative 12. And that's the feet per second per second. Okay, Vt, velocity was feet per second. The rate, derivative means rate. Feet per second per second. So feet per second square. Final.